Asikati kumaring tunaweza 0s kati uhusiano upi iwoyo. So theta x is equal to 0s, theta y is equal to 0s, theta x is equal to theta y is equal to 0s. Talea foundation yani yedu. So this is the first thing. Tulakufuda ne closure yechi ye ideal. Okay, closure under addition. We are trying to test as the first step. Okay, total theta x is equal to theta y is equal to 0s. Hence, theta x minus theta y. Remember, now we have this property a minus b element of ideal. So that is our concept for today. Homomorphism of rings. Zviripo padocument randakatumira nezuro makumi ano rataingoshandisa paya. Okay, taita homomorphisms of rings. Let's talk about a kernel of a ring. Then talk about two first example presents. Then we call it a day. Muso watisangana kuzoita a quotient ring. Nokuda kuita irreducedness concept of quotient ring, but about homomorphism, we can answer my questions to Madame. So then we'll be done. Okay. So borrow the concept homomorphism of groups. So I'm going to find out homomorphisms of rings. Mapping. So homomorphisms of rings in mapping between two what? Two rings. So let's see that two rings, a ring R under a addition and multiplication, and ring S, right, under this operation and under star, right, two rings. Then a mapping theta R on S is called a ring homomorphism for R to S if, right. Let us define ring homomorphism in the two conditions. Theta R, then this operation, not in the operation here, theta S is equal to theta R plus S. Okay, I want you to observe something here. Remember, take my group of homomorphism, we would say theta AB is equal to theta A theta B. So I am a group homomorphism. Yes, right. Tight homomorphism, it preserves the group what? Operation. We are preserving a group operation. So that is what is happening here also. So remember, a ring carries two what? Operations. Here we have addition and multiplication, and here we have this operation and star. That is a ring, the properties of a ring. So here we are saying theta R operated upon this operation theta S. Okay, it is the reverse. But emphasis in panel. we are saying theta r upon this operation, this is this one, the first one. Then katakumiri takushandisa plus. Tukushandisa ma operations akanangana. Maiwana pattern yacho. Ngatinyatsobata ndo NB yangechitaurwa iya. Nota bene nyatsobata kuti G. Right, item 2. Total theta r star theta s k. Here we are operating with multiplication. Theta r dot s. I think you need to edit. Remember not is the lesser plus s, but it should follow this pattern. It is star nani na dot multiplication. Right, so that is a homomorphism of rings. Then tinema types of homomorphisms. Tine monomorphism. Remember takati image of monomorphism kana iri 1 to 1. Tine epimorphism kana iri chi surjective. Then endomorphism, it's a new term now, takuma ring. Endomorphism, tatina kuitaura. If theta is an epimorphism from R to R, okay? It's a mapping from R to R. Theta is R to R. A ring mapping itself and being surjective, being an epimorphism. So theta it's an endomorphism. It's an endomorphism. It's a special type, a special kind of an epimorphism. But this ring is mapping into itself. It's not meant, we are not saying R is being mapped to S, but R is mapping in itself and being an epimorphism. So this type in happens endomorphism. Then lastly, the fourth one, we have isomorphism. Bijective. Isomorphism irangara from the group homomorphisms and the isomorphism meaning bijective. Panaka kapo totsika mafuta that define out the homomorphism of a ring. Tikataura kuti tinofanira kutedzera order yakarongwa ma-operations edu kana takunyora ma-statements of homomorphism edu. Then toziva those 4 kinds of homomorphisms of rings. Tine monomorphism, epimorphism, isomorphism atatu kuziva kudhara. Then the new one, the endomorphism, which is an epimorphism of a ring into itself. It's a special type. This tiri kuma groups taineya is automorphism. IBG waizvinepa into itself in bijective. And it's right. I know my definition of terms. So let us be quick to go to some lemmas and proofs. Kernel of a ring. Kernel of a ring. That's all. That's all. let us go back to groups. Right. Homomorphism of groups. Takati chinonzi a kernel of theta. Homomorphism of groups. Takati iseti vakaita sei.
E.g. akamapa onto EK akawanda.
Tight theta G is equal to EK. Saka taitika na theta G is equal to EK. Tikangosvika kuna EK, therefore G is an element of kernel theta. Kuma groups. We are borrowing the same pattern. It is the very same idea. But EK cannot identity rings. Identity rings. Remember, axioms rings. Identity number one is addition chat. Yes, okay? Multiplication hakuna takati same group and multiplication. But to addition, it's a full group, a full adjoint group. You don't have to identity anymore. Saka we are solid sure put identity. Here ring, yani deserve. That we come back to papa. My rings, takakutara nezo identity. Takunyora are zero. Because identity of addition is what? Zero. That's what change it papa. So we are saying any member of a ring R can be mapped to 0 one ring S and a member ya kernel theta. Tutese tine rings at 2 ring R and a ring what? S. Right? Tine elements at x1, x2, x3, x4. Then we have S here with some abstract elements, but we also have 0 here. 0, which is our identity. Are we together? Then x1 can be mapped to this one, x2 can be mapped to this one, but x3 can be mapped to 0, x4 mapped to 0, which is our identity. This is right. Shaka, the Afma members are kernel theta. X3 and X4. So we have a special set X3, X4, which is being mapped to the identity 0, which is in S. So this special type of a set, they are attributed to kernel theta. Kernel of a ring. So it is the same concept, but yango chinja pekwenda. So let theta R mapped to S be a ring homomorphism. The kernel of theta K say is given by. That is the definition now of the kernel of a ring. Okay? K a kernel theta is equal to right R element of R, where theta R is equal to 0. 0 S. 0 S. 0 S is identity
Yes.
So we are mapping an element R by the homomorphism theta. so that theta r is equal to identity S. Tricadaro, we can conclude that R is the element of kernel theta. And it's alright. I think it's clear. Lemma. An important lemma, which is also an exam area. Let theta r, this is our lemma, let theta r, theta dot r mapped to S, be a ring homomorphism, be a ring homomorphism, then kernel of theta is an ideal, of R. Is an ideal of R. Okay, this is our question. We want to prove that if theta, the homomorphism theta R mapped to S, be a ring homomorphism, then kernel of theta is an ideal of R. So, we want to know our destination. What is our destination? We want to prove an ideal. What should you know? We should know about the properties of kernel of a ring homomorphism. And you want to prove whether this kernel is an ideal. Remember the properties of an ideal. We have 3 of them. How do we prove whether a certain element is an ideal? Yes, sir. Yes, it should be both left ideal, right ideal. Satisfy hence it is an ideal. We need our R element of I. Then to hence it's an ideal. Proof. This proof is very interesting. Proof. Let xy be elements of kernel of theta. We are borrowing 2 members from the first ring R together. 2 abstract members X and Y, and suppose they are the elements of kernel of theta. So, what does it mean? By definition, we are saying theta R, where R is a member of a ring R, is equal to identity of S. So, we follow the same pattern. We are taking theta x is equal to 0s, identity of S. I'm breaking that statement so that you understand where it came from. Then we also have theta y. We are testing both of them is equal to 0 S. Okay? Why? Because we are told by the initial condition that both of them, they are the members of kernel of theta. So both of them should link to 0S. Together. So what do we conclude from there? We conclude that theta x is equal to theta y is equal to S. Right? Are we together? Yes. We are stating the statement of homomorphism. Theta x minus theta y is equal to, according to the properties of homomorphism, what does this become? Theta x minus y. We are stating homomorphism in this way. Remember that we said theta xy according to homomorphism is equal to theta x theta y. But now we have said theta x minus theta y, it should be theta x minus y. It is the pattern of homomorphism which we have borrowed. Pabudera. Thank you. Since theta is a homomorphism, i.e. 0 is equal to theta x minus y. Okay. Makwanisere ku interpreter zvataurwa. Right. Theta x ndiyani? Theta y ndiyani? 0. And theta homomorphism here, theta x minus theta y is equal to theta x minus y. Theta x 0, theta y 0. So we have a 0 here. Which is equal to this new expression. And so theta x minus y is equal to 0, which is an identity. Theta xy is mapped to an identity of S. Remember those zeros now 0 and S. So it's a kernel. Because 0 is identity. This thing chamepewa kuchi kernel. Yeshoka. Saka zoreve kana theta x minus y yaenda ku kernel. Zvinoreva kuti x minus y is an element of kernel theta. We are saying if theta b is equal to an identity, it means that b is an element of kernel G theta. That is the basic statement we have to conclude this one. Everything which is linked to the identity is a member of a kernel. That's data about the closure under addition. Closure under addition. Remember, pataka introduce my ideal is take the first lemma part A in not A minus B is an element of I, A minus B. Saka pana pota nani? X minus Y, which is the part of an ideal. X minus Y will follow A minus B. With definition yechi ideal. Remember, that tukufauza kwa tukuenda tunakuprova kuti ideal here. So tunafange to include my properties ideal. Saka X minus Y ya include and remember ya kernel chi theta. Here. Now to test manage ideal. Left ideal, right chi ideal. Saka taku borrow another member. In our R element of R. R element of R. Okay? If R is an element of R, then theta XR, okay, XR, EIG, drop tester, XR, right, I found it, thank you. But 3 under homomorphism. XR 3 under homomorphism. So theta XR according to homomorphism okay? Theta XR 3 under homomorphism is equal to what? Let us conclude that one. Theta X theta R. Are we together? No floor. But zvatasteta panapa kuti X na Y ma element ani kernel. Then theta X ndiani 0. Let us come back here. What is theta 0? Theta X 0. Theta R. So we are concluding that theta XR is equal to 0 times theta R 0. Shaenda kupi? Hello? Shaenda kupi? Yes, shaenda kwa identity inova chi kernel. Then XR is an element of kernel theta. The right ideal yapina kernel. This is property ideal ne kernel. Zvifambirana. Ndizvona zvipfekaniso nokufira nditika. Okay, in the same way, capital theta, Rx, theta, Rx, what is this? Left ideal. This one, under homomorphism, in it achieve theta R, theta X, which is equal to, what is theta R, or theta R we have it, we don't know the result. What is theta X?
0.
0. Theta R times 0 is equal to 0. Hence theta Rx is also equal to 0. Hence it's a member of a kernel of theta. 0 is the identity member. So what is our conclusion? Rx is an element of kernel
Theta.
theta. Okay, tine 3 statements here. Tine the first one, yatatanga testa ye closure under addition. Tikati x minus y, a element ya kernel chi theta. ndizvova plus xr is also an element of kernel G theta. Rx is also an element of kernel theta. So what is our conclusion? We are saying x minus y, comma, Rx, comma, xr are all elements of kernel theta. But Rx and xr are left and right ideals. Then it's an ideal. Ideal element ya kernel G theta. Then kernel theta is an ideal of R as required. Hence, kernel theta is an ideal of R as required. The proof is complete. The proof would be complete.
This all.
All right. But let's talk about the abstract. Maybe Papa summarize as we go and summarize a man. Right, can I drive while zive first time? Maybe maybe at start. Ask an option farmer for the second time. How on? Right. Let theta R as be a ring homomorphism. Then kernel of theta is an ideal of R. So far, what is your about kernel of theta? But G. So far, what is the ideal of R? G. Because you are one charge. I'm a 1. Usually, right? Kernel of theta is I do not say so to come to the question is that the link which prove this lemma. Then talk about homomorphism. You know, from the irimo, kernel, you know, from the irimo, ideal, you know, from the irimo. So the first thing is to borrow two elements x and y and state that they are the element of kernel theta. And to start with no relay. Theta x is equal to 0 as 0 identity. Okay. This is a mistake of Mr. 0 to kernel eguma groups. 0 are kupana kuma kernel h emali. That is n k. Askati kuma ring tunesa 0 s kati siano upi iwoyo. So theta x is equal to 0 s, theta y is equal to 0 s. Theta x is equal to theta y is equal to 0 s. Talia foundation yani yedu. So this is the first thing. To put a closure yechi ye ideal. Okay, closure under addition. We are trying to test as the first step. Okay, total theta x is equal to theta y is equal to 0 s. Hence, theta x minus theta y. Remember, now this property A minus B element of ideal. So theta x minus theta y is equal to, but tonight you're under chi homomorphism. Stage tata is equal to left hand side in it as 0. Y theta x in the 0, theta y in the 0 according to this. Saka innovator chi 0 is equal to theta x minus y to right hand side. 0 oil I thought the expression that it satisfy condition kernel theta. Because this expression theta x minus y is mapped to the identity in the ring S. So, we satisfy this pattern, kernel theta. Right. So to attach, hence this thing, this whole thing, x minus y, is an element of kernel of theta. That is the first step. What is the second stage? The second stage, I think, it is similar than the first. To borrow another element, R, the element here ring R, and then tapuchishanga na R A R, left ideal, right ideal. Okay, tapuchichi saka. Theta x R ndiani toro homomorphism yacho isi tiri kuziva already theta x is 0 zvese tinofanira kuzosvika kuna 0 handitika tochiti theta x R is equal to 0 zvoreva kuti x R element yakernel theta. Each stage yatiri kufamba handitika inofanira kuti element yestage iyoyo yanikwa kernel chi theta. Tine 3 major stages. Toita Rx, and it tozvi expand according to homomorphism, zvotisvitsa futi kunani kuna 0. Tota Rx element yakernel chi theta. Then tozvilinga sei takubatanidza x minus y, xr, rx, tot ma elements akernel theta. Tochiconclude kuti according nezvataurwa kernel theta is an ideal of R. I think take a follow over and over again. Batika. Last question for today. Let R be a ring I an ideal of R define theta R over I by theta R is equal to R plus I for all R element of R, then theta is an epimorphism. Is an epimorphism. Right. It more the current in my worksheets that one. Alright. Let us note the following. Chicha tapiwa R as a ring, tapiwa I as an ideal. Right. There's a new thing. Theta is equal to R over I. R over I is called a quotient ring. It's a quotient what? Ring. Theta is okay. R is a ring. I is an ideal. R over I is a quotient what? Pane question next presentation to prove that R over I is a ring. but nothing is detailed. That's why it's a ring. Right. Define that quotient ring by theta r is equal to r plus I. To my rules, it to not guide the proof. Whenever we are doing a proof, let us refer back to that rule. This one. Right. So theta r is equal to r plus I. R plus I. Tisatapinda ku detail. Ndiudziwe kuti theta x ndiyani. No. I Kernel. Kernel utaita sei tava. According to this rule, theta r is equal to r plus I. So theta x is x plus I. Yeah, tatigatisana ipapo tisatapina muproof. Inoita equal to 0 kana iri Kernel wanditi. What is theta y?
Y plus I.
Theta y is equal to
Y plus I.
Y plus I. It's a definition here.
Quotient ring.
Homomorphism under a quotient what? Ring. Okay? Right. There's what we call coset addition. Coset what? Addition. Tikati theta x plus theta y. Theta x plus theta y. Quotient addition yatula kuita iyi. Coset addition, I mean. Okay, what is theta x?
X plus I.
X plus I plus. What is theta y?
Y plus I.
Y plus I. Okay? Here we just add x and this is equal to x plus y in brackets plus I. Usandifunza ukuthi 0 is not to I. Ndo zvazviri. Zvazviri ndo zvazviri. Then theta x theta y is equal to, right, that's when that theta plug out my results yi. Theta x theta y multiplication here under my ideals. Okay, we are saying what is theta x? X plus I multiplied by what is theta y? Y plus I. Right, the multiplication is simple. We are not doing illustrator for algebra here. X plus I y plus I. We are multiplying this and at square expansion of brackets. Take note of that. We are just multiplying x and
Y.
You have x, y, then total plus I. That is the result.
Measure to support.
Why until kudaro?
Measure to support I squared.
And why? Pattern here is theta r is equal to r plus t I. Any result, follow that r plus t I. Pata eta panapa tabuda na x plus y var ma brackets and x plus y notch r. ndochi r plus I. Patamultiply takuita xy plus chi I. Still xy wedu ndochi ndo r. A follow a rule. The quotient chi ring. Saka shene mkufedu tuda kumhanya ipapa. Kana tabata izvo kana tawirirana. Then let us go into the proof. Okay, homomorphism. Homomorphism is subjective onto. Izvo kana chiti subjective kana chine function of x is equal to something. Tunofaa kubva ku something tidzoka. Inverse. Tunofaa kukwanisa kutsvaga chi inverse. Inverse voreva kuti kubva kuzasi chienda kupi soro. Do homomorphism andivira was subjective. Tatoda kuprova kuti this thing is subjective, is onto. Right. Chitsamanga, we are choosing two abstract elements of R to let x, y be elements of what? Of R. Then, to test homomorphism under addition, homomorphism under multiplication. And it define about homomorphism rings. No patrick by Baptist testers. So, first of all, we want to test homomorphism under addition, that is theta x plus theta y. Remember, but it tempts to flip back the definition of homomorphism under rings here. Tati tinobva back tichienda ku original one. Tati kutanga edda. Indeed. Well, this is equal to, according to this result, x plus I dot theta x and theta plus y plus I, which is equal to, we add x and x plus y plus I, which is equal to, right, it's interesting now, it's theta x plus y. Okay? Ruita ibatere. Theta r is equal to r plus g I. So under addition, theta x plus theta y is equal to x plus I plus y plus g I. So add x plus y plus I. This format ya tevera g, format ya r plus g I. Right. Let x plus y be r. Saka kana tina theta r, tina r plus I. Kangweta r plus g I. Tikashidisera kumakere, it is theta what? R. Tika pure r plus I is equal to theta what? R. But this is that x plus y and the r. But this is equal to theta x plus, those I take back up. So now x plus y plus I. This one, Saka ichi r check it. This one, Saka no theta chi r, but r and the x plus g y. So what does it mean? When an expression iyo, it result the expression iyo. Chicha formula up. Homomorphism guys. Homomorphism result. So the pakati zvese zvati leader to this link. Togona kunyora tichiti theta x plus theta y is equal to theta x plus y, which is a homomorphism. Right. Remember that homomorphism reverse original statement and homomorphism inotangira o ichiya kupi o isitatanga kumashure sapa original statement. Right. Also, right, this is item 1. Item 2, taku tester under multiplication. Same. Statement 2, apata tester nechi addition. Taku tester ne multiplication. Theta x theta y is equal to theta x theta y is equal to what is theta x? X plus I multiplied by what is y? Y plus I. Okay. According to the multiplication in a quotient ring, xy plus I. The same pattern. Ya ri ya dzoka. So this is equal to theta what?
xy.
xy. And if we link this, that homomorphism and theta x theta y equal to theta x. Therefore, theta is a surjective homomorphism and hence an epimorphism is required to appear. Therefore, theta is a surjective homomorphism and hence an epimorphism is required. Right. I think this proof is fairly short. Right, I don't think it's an amra, but it is short and straightforward. Chakakosha part of this rule. Theta r is equal to r plus 2I, number 1. Number 2, kuzoti tikam edda, chichinoitika. Tikam multiplier, chichinoitika, tikazama results I. Chichitesta kupi, kuno. My definitions 2, a homomorphism I, total under addition, theta x plus theta y is equal to x plus I plus y plus I, so the adder plus I, which is equal to theta x plus I. Ukakangana the facts iyo, unorasika muproof andika, asikana this fact iri mu brain kuchiningirikira. Uchita process ye simplification pana paunongosvika not this is the thing. This thing is equal to theta r, but r will r x plus y. The next thing is to link the first statement and the last expression yato homomorphism. That stage I just say rapera moba ekapo muenda ku multiplication and you follow the same process. Then the proof would be complete. Sando kumbira ukuvunza proof ine stages manga ari important. to the addition
Multiplication.
tichizvilinga kuhomomorphism. Epimorphism usubjective mamsoro ukubuda papi. Right. Panofanira kuemphasizwa ipapa. Awufanira kuconclude kuti epimorphism ndozingaziva kuti epimorphism chii. Tinoona function iri subjective. Or onto. Tiri kucalculus. Chaitu kana function iyo ichitsvaga inverse. Ndizvo ka? Ndizvo. Ichitsvaga chii? Inverse. Zvoreva kuti iri chii? Onto. Inverse zvinorevei? Reverse back. Inverse ichi? Reverse. Saka isusu homomorphism inoti theta xy is equal to theta x theta y. No definition chaicho yechi yehomomorphism. Ko inverse iri kuti chii? Iri kutangira kuti theta
X
theta y zvese zvaunoita pakatapa zvikazokonkluda kuti theta x y tabva uku tichirivhesa kudzoka kupi uku. Process dzawaita apa dzikakulida uku wobva wati hence it's an epimorphism kana kuti subjective. Taita reverse theta x theta y ndobva yaita chii?
Theta x
y. Right? Zvaiteera. Okay. So for today I think I can conclude